Welcome to the seventh and final part of Building Robots System Integration. My name is Gaspar Škulj from University of Ljubljana, and today we will discuss automatic operation of a robot and importance of plant extensibility. At the end, we will specify the last project assignment. Total manual control of a robot is useful if we want the robot to make actions exactly as the human operator commands. But the human operator can make mistakes, or in some cases needs a bit of help, or even doesn't want to control the robot all the time. In these cases, the robot should make some actions or motions automatically. If all actions are controlled by the operator, the robot is working in a manual mode. If some actions are controlled by the operator and some by the robot is working in a semi-automatic mode. And if all actions are controlled by the robot, it works in an automatic mode. With our control interface on a smartphone, we can control mobile robot in a manual mode. And now we want to extend its functionality to work in semi-automatic mode by introducing a safety feature. The robot should not move forward if an obstacle is detected closer than 20 centimeters with the ultrasound sensor. To add this feature, we have almost everything already prepared. The main communication module that has both speed references received from the user interface can ask via CAN bus for an ultrasound distance measurement from the forward-facing sensoric module at every update. Based on this measurement, the speed references are modified before forwarded to the control module. While the human operator is still controlling the robot can also automatically prevent actions that could cause a collision, making robot's movement safer. Designing a robot to operate in a safe way is another very important task and should be taken very seriously, especially if the robot will work in automatic mode. Automatic operation could mean that an operator-defined program is being executed, where every motion is programmed, or that the robot is deciding on its own how to move. In any mode, manual, semi-automatic or fully automatic, the robot must not cause damage to people, equipment, or itself. One way is to confine the robot to a robotic cell where it operates in a very predictable environment. Another option is to make the robot small, light, move slowly, and be able to detect collision or even prevent collision before it happens. Making the robot's exterior soft, without sharp edges and without possibility for pinching, also makes a robot safer. And robots, called collaborative robots, are made safe enough they can operate alongside people. In our case, the mobile robot is very light, moves slowly, and doesn't have enough power to cause any damage. However, the robot could also be programmed to monitor power consumption and measure sound of the gearbox to detect any signs of abnormal behavior. For example, higher current than expected could indicate unexpected load or obstruction in the drivetrain, and a change in gearbox noise can be a sign of damaged gears. The robot would, in such case, stop and alert the operator. When designing a robot, it is just impossible to predict all possible scenarios the robot will be used for, or how specifications may change during development. If we accept that, we can make the design flexible enough to allow for future modifications and upgrades without major redesign of the system. And this shouldn't apply only for the software part, where extensibility is simplest to implement. Mechanical and electrical hardware should also allow for additional connections or modifications of existing connections. In our case, we can use the same servo motor design to build a mobile robot or an articulated robot just by using few different additional parts. Because each servo motor has its own power supply, geometry of robots can be easily varied. The common design of the 4 PCB modules also allows to change only a part of the system by exchanging one module for another. The communication module has access to 5 different communication channels to connect with other devices. By using I2C, we can easily add additional sensors, like inertial measurement unit or a temperature sensor. Each module has its own microcontroller that makes them independent and allow for simple upgrades to their software functionality without affecting other modules. For the users of the system to benefit from the extensibility options, documentation for this purpose should be provided. This can be done in several ways, depending on what the designers are willing to share. The system can be presented as a black box, for which only the interface is disclosed. On the opposite side of the spectrum, there is an open source option where everything is disclosed and, depending on a specific license, also available for modification. Required detail level for documentation of a specific design also depends on level of adherence to standards. A lot more documentation is needed if non-standard elements are used in the design. In the design of our servo motor, we intentionally use a well-established ESP32 microcontrollers in combination with common electronic and mechanical parts. 3D printing has also become a mature, well-documented and accessible prototyping technology. Use of open-source development tools like Arduino IDE, KiCad, FreeCAD and Prusa Slicer also give us access to online support and contributions by their communities. Your last task is to extend the program from the previous task with additional functionality. Create programs for 2 ESP32C3 and S3 microcontrollers so that when a number is sent by pressing the button on previously developed webpage for the first microcontroller, it only prints forward if the physical button on the second microcontroller is also pressed at that time. For communication between the 2 microcontrollers, use CAN bus or alternatively I2C communication. By designing a safe and extensible robotic system, it can be used to perform various tasks alongside people helping them by doing repetitive, precise or strenuous operation. But tasks can change, and in response, robots can be modified with new programming, additional hardware or improved user interface. If we know how to build a robot from individual components, we will also be able to improve them. Thank you for watching.